Hey everyone, and welcome. In the next few minutes, we're going to tackle what is arguably the single most crucial skill in the world right now. Seriously, it's the key to so many opportunities in our economy, and we're about to break down exactly why.
So, let me ask you something. Just take a second and really think about it. With everything changing so fast, AI, automation, you name it, what's the one technical skill that companies are just desperate to find? The one they literally cannot hire for fast enough?
And the answer? Well, it's crystal clear. Data analytics. And look, this isn't just a hunch. The World Economic Forum flags this as the #1 technical skill gap for companies, and they project this demand is going to hold strong all the way through 2030. Think about that. That's nearly a decade of huge sustained demand.
But here's the thing about a skill gap. That isn't bad news. Not for you anyway. It's a massive opportunity. It means if you have this skill, you are incredibly valuable. It's exactly why LinkedIn consistently has big data skills in their top 3 most in-demand hard skills. This is where the jobs are, and it's where they're going to be for a long time. Okay, so how do we actually start speaking this language of data? Well, it all begins by decoding what are known as the 4 V's of big data. You can think of these as the absolute essential grammar you've got to know. I know, big data can sound kind of huge and abstract, right? So let's use a really simple analogy to make this click. Just picture a massive, super busy train station. I promise, this one image is going to make these core concepts stick.
All right, so here's how our train station breaks down those 4 V's. First, you've got volume. That's just a massive, overwhelming crowd of people. Easy. Next, velocity. That's the crazy speed with trains pulling in and out every single minute. Then you have variety. It's not just passengers, right? It's cargo, it's digital tickets, it's food orders from the kiosks, a huge mix of different data types. And last, but maybe most important, veracity. That's all about trust. Every single ticket, every pass has to be validated, or the whole system just falls apart. So volume, velocity, variety, and veracity. That's the foundation of the whole thing.
And this isn't just theory, right? These concepts map directly to the real-world tools the pros use every single day. For that high-velocity data streaming in, you'll use something like Kafka, which acts like a central nervous system. For the massive volume, data gets stored in huge systems like Amazon S3. To handle all that variety, companies build what are called data lakes to hold everything. And to make sure you've got veracity, they use data quality dashboards to keep an eye on accuracy. It's a real toolkit for a real job.
Okay, so we've got the concepts down, but what does this stuff actually do? What does it look like when it's out in the wild? Let's get into the real-world impact big data is having right now.
Okay, check this out. A fantastic example from manufacturing. General Electric, huge company. They use predictive models that listen to the constant stream of sensor data from their massive turbines. And the result? They've cut unplanned downtime by a staggering 20%. That's millions and millions of dollars saved, all by just paying attention to what the data was saying.
And the impact goes so far beyond the factory floor. In healthcare, there's an incredible AI tool that can analyze over 300 different data points from hospital records. Talk about handling variety and volume, all to find the very earliest subtle signals of dementia. This is genuinely life-changing stuff.
And just to show you how widespread this is, let's look at farming. An agricultural co-op in Spain managed to boost their olive yield by 15%. How? By combining satellite images with data from little sensors they put in the soil. So you see, from factories to farms to hospitals, data is absolutely transforming everything.
But, with all this power comes a whole new set of rules and responsibilities. It's not enough to just know how to use the tools. You have to understand the ethical landscape you're operating in. So let's talk about that. You've got to think of data as a coin with 2 very different sides. On one side, you have this incredible potential for efficiency, innovation, you name it. But on the other side, you've got some serious pitfalls. Things like algorithmic bias that can accidentally create unfairness, really expensive regulatory mishaps, and of course, huge data privacy risks. Being able to navigate this is absolutely essential.
So, how do you navigate that tricky landscape? Well, you start building out your professional ethical toolkit. This means you get familiar with stuff like anonymization to protect people's privacy. You use data lineage to track where your information came from. You actively work to reduce bias in your models, and you even think about the environmental footprint with things like green AI metrics. Honestly, this awareness is just as critical as the technical skill itself.
So you get the why, you get the what, and you get the complexities. The final, and maybe most important question is, how do you actually start? How can you take that first step like today?
Look, here are 3 super simple, practical tips to get the ball rolling. First, start small. Seriously, don't try to boil the ocean. Analyze a small, manageable file before you even think about a massive one. Second, visualize your data. Use a tool like Power BI to actually see it. You will spot interesting things and weird problems way faster than just staring at code. And third, and this is a big one, don't go it alone. Join a community like Kaggle Online or find a local PyData meetup. Learning with other people is an absolute game changer.
I want to leave you with this one thought. Think of these big data fundamentals as the grammar of our entire digital economy. If you ignore them, you're essentially trying to get by while speaking with yesterday's accent. You risk not being understood, and maybe more importantly, not understanding the world that is literally being built all around us.
The data is everywhere. The data sets are just sitting there, waiting. So the only question left, really, is how are you going to translate them into value?